Hi guys, this is Manohar and welcome to Tutoralz. Today in this video, we are going to solve some more problems based on the pipes and cistern concept. Actually, this is the second part of pipes and cistern tutorial. If you haven't watched the first part, I recommend you to please watch first part of the pipes and cistern tutorial so that you can come to know what is the concept of pipes and cistern and also what are the methods we use to solve the problems. Now let's see some more problems based on the pipes and cistern concept. Now let's look at our first question. They are saying that it takes 6 hours for 3 pipes X, Y and Z to fill a tank. When 3 worked together for 2 hours, Z was closed. X and Y filled the remaining tank in 7 hours. How many hours would it take Z alone to fill the tank? So we need to find out what is the time taken by Z alone to finish the entire tank. So they are saying that X, Y and Z all together can finish the entire tank in 6 hours. So there is 1 hour work is, our efficiency is 1 by 6. Okay. So x plus y plus z can finish the entire tank in 6 hours. So their efficiency or 1 hour's work is 1 by 6. Now they are also saying that x plus y plus z have started to work together and after 2 hours they have closed the z. Okay, x plus y plus z have started together. Then after 2 hours z was closed. So up to 2 hours they have started working together. Okay, up to 2 hours they have worked together. Now up to 2 hours, what is the part of work that is completed? There's 1 hour work is 1 by 6. Now they have worked for 2 hours. So they have completed 1 by 3 part of the work. Okay. See here they are saying that x plus y plus z have started to work together and up to 2 hours they have working together. And after 2 hours they have closed z. So up to 2 hours they might have finished some part of the work. Now what is the work that is completed? 1 by 6 into 2, that is 1 by 3 part of the work is already completed by x plus y plus z after working for 2 hours. Now what is the part of work that is left over? That is 1 minus 1 by 3. So 2 by 3 part of the work is left over after working for 2 hours. Now they are saying that x and y have worked together for 7 hours to finish the remaining part of work, that is 2 by 3. Okay, now they are saying that x plus y have started to work together for 7 hours to finish the remaining part of the work, that is 2 by 3. Because z is already closed. Okay, after working for 2 hours, z is closed. Now only x plus y is working together for 7 hours to finish the remaining part of work. Okay, now if we send this 7 to the right hand side, I will get x plus y equal to 2 by 7 3 is 21. So x plus y's 1 hour efficiency is 2 by 21. Now if I substitute this x plus y's value in the x plus y plus z, I will come to know what is the total time taken by z to finish the work. Now I am substituting this value, so I will get 2 by 21 plus z equal to 1 by 6. Now if I send this 2 by 21 to the right hand side, I will get z equal to 1 by 6 minus 2 by 21. So the LCM of 6 and 21, that is 21 2 is 42 and 42 is divisible by 6. So the LCM will be 42 and 1 by 6 into 42, that is 7 minus 2 by 21 into 42. 2 by 21 2 is 42 and 2 is 4. So 7 minus 4 by 42. So we will get 3 by 42. 3 ones 3 and 3 fours 12. So 1 by 14. So 1 by 14 is the 1 hour's work of Z. Okay. 1 by 14 is the 1 hour's work of Z. Now Z totally takes 14 hours to fill the entire tank. Now let's see the second question. They are saying that 2 pipes P and Q can fill a tank in 14 hours and 16 hours. When both pipes are opened together, then it took 32 minutes more time to fill the tank due to some leak. Find the time taken by leak to empty the completely filled tank. So we need to find out what is the total time taken for leak to complete the entire tank. Okay. Now they are saying that P can fill the entire tank in 14 hours. So P's 1 hour work or efficiency will be 1 by 14. And also they are saying Q can fill the entire tank in 16 hours. So Q's 1 hour work or efficiency will be 1 by 16. Okay. Now they are saying that there is some leak here for the tank. Okay. Consider there is a leak here for the tank. So to fill the entire tank, if both P and Q are opened together, due to this leak, it is taking 32 minutes more time than expected. Okay. To fill the entire tank due to some leak, if both pipes are opened together, it is taking 32 minutes more time. So to find out what is the total time taken for leak alone to finish the entire tank, first of all we need to find out what is the total time taken for P and Q to finish the entire tank. Okay, See, to find out what is the total time taken for leak to finish the entire tank, first of all we need to find out if there is no leak, what is the total time taken for P and Q to finish the entire tank. Then we can find out what is the total time taken for leak to finish the entire tank. Okay, now I will solve this so that you can understand. See, first of all we need to find out what is the total time taken for P and Q alone if there is no leak to finish the entire work. So I am adding this both the efficiencies, so I will get 1 by 14 plus 1 by 16. So the LCM of 14 and 16, that is 16 sevens 112 and 112 will be divisible by 14. Yeah. So the LCM will be 112. So 1 by 14 into 112, that is 8 plus 1 by 16 into 112, that is 7. So I will get 15 by 112. This is the 1 hour's work of P plus Q. Okay. 1 hour's work of P plus Q is 15 by 112. So P plus Q totally takes 112 by 15 hours to finish the entire work. Okay, to finish the entire work, P plus Q takes 112 by 15 hours. Now we need to find out what is the total time taken for this leak to complete the entire tank. Now they are saying if both pipes P and Q are open together, due to some leak, they are finishing the work 32 minutes more time. Okay. See here, understand this. P plus Q are open together. Now, due to some leak, so I am considering leak as R here. Okay, I am considering leak as R here. Now I am giving negative sign to the R because R is removing the work. Okay, here R is removing the work. That's the reason I am giving negative sign to the R. Now they are saying that it is taking 32 minutes more time than expected due to this leak. So this 32 is given in the form of minutes. So to convert it into hours, I am dividing it by 60 minutes. Okay, 32 is given in the form of minutes. So to convert it into hours, I am dividing it by 60 minutes. So I will get P plus Q minus R. If 3 are working together, 15 and 60, the LCM will be 60 and 112 by 15 into 60, that is 15 4 60 and 112 into 4. 100 into 4 will be 400 and 12 4 48. 448 plus 32. So I will get 480 by 60. So if I cancel this, 6 1 6 8 48, so 8 hours. So P plus Q minus R totally takes 8 hours to finish the entire tank. Now we already know what is the efficiency of P plus Q here. Okay, I already know what is the efficiency of P plus Q here. Now if I substitute this efficiency of P plus Q, I will come to know what is the total time taken by R to finish the entire work. Okay, now I am substituting this value, I will get, see here, P plus Q minus R can complete the total work in 8 hours. So 1 hour's work will be 1 by 8. Okay, can finish the total work in 8 hours. So 1 hour's work is 1 by 8. Now if I substitute this P plus Q efficiency, I will get 15 by 112 minus R equal to 1 by 8. Now I am sending this R to the right hand side and 1 by 8 to the left hand side. So I will get R equal to 15 by 112 minus 1 by 8. Okay, I am sending this R to the right hand side and 1 by 8 to the left hand side. So I will get R equal to 15 by 112 minus 1 by 8. So the LCM of 112 and 8, that is 112, because 112 will be divisible by 8 also. So that's the reason. And 15 by 112 into 112, that is 15 minus 1 by 8 into 112, that is 14. So it will get 1 by 112. So C alone takes 112 hours to finish the entire tank. This is the 1 hour's work. Okay, this is the 1 hour's work of C, that is R. Okay, sorry, this is the 1 hour's work of R. So R totally takes 112 hours to finish the entire tank. Okay, now let's see how LCM or units method works to solve the same problem. See, they are given that P takes 14 hours to complete the work and Q takes 16 hours to complete the work. And this is hours here and units here. Now the total amount of work to be done is the LCM of 14 and 16, that is 112 units. So this is the total amount of work to be done. Now P is completing total work in 14 hours. So P is working per hour 112 by 14, that is 8 units of work. And also Q is completing 112 by 16, that is 7 units of work per hour. Okay, now they are saying that due to some leak here, okay, due to some leak in the tank, if both pipes are open together, it is taking 32 minutes more time to finish the entire tank. Okay, now P and Q are open together. Now due to some leak here, it is taking 32 minutes more time than expected to finish the entire tank. Okay, now we need to find out what is the total time taken for this leak to finish the entire tank completely. Now, first of all, we need to find out P plus Q total time taken to finish the entire tank to find out what is the total time taken for this leak to complete the work. Okay, now P plus Q totally do 8 plus 7, that is 15 units of work per day. So to complete this 112 units of work, P plus Q totally takes 112 by 15, that is 112 by 15 hours. Okay, see here, we need to find out what is the total time taken for leak to finish the entire tank. Now to find out that, first of all we need to find out what is the total time taken by P and Q to finish the entire tank if there is no leak here. Okay, if there is no leak, what is the total time taken by P and Q to finish the entire tank? That is 112 by 15 units. Now they are saying that P and Q are open together and due to some leak here, the work is completed in 32 minutes more time than expected. Okay, due to some leak here, if both pipes are P and Q are open together and due to some leak here, that is R, it is taking 32 minutes more time than expected. Okay, I am considering leak as R here and also giving negative sign because R is removing the work. That's the reason I am giving negative sign here for the R. And also it is given 32 in the form of minutes. So to convert it into hours, I am dividing 32 by 60. Now we will get P plus Q minus R equal to the LCM of 15 and 60, that is 60 and 112 by 15 will be 15, 460 and 112 into 4, that is 100 into 4 will be 400 and 448 plus 32, the LCM is 60. So we will get 480 by 60, that is 8 hours, 168. So P plus Q minus R totally takes 8 hours to complete the work, that is 112 units of work is completing in 8 hours. So per hour it is doing 112 by 8, that is 14 units of work. Understand this? P plus Q minus R is totally taking 8 hours of time to finish the entire tank. So in 8 hours they are completing 112 units of work. Okay, so per hour they are completing 112 by 8, that is 14 units of work. Now we have known what is the efficiency of P plus Q minus R and also P plus Q. Now if I substitute the value of P plus Q in the P plus Q minus R, I will get what is the efficiency of R, that is what is the total work that is done by R per hour. Now I am substituting this P plus Q in the P plus Q minus R, I will get 112 by 15, sorry, I need to substitute the efficiency, right? Sorry. So here we have got efficiency, that is 14 units. So I am also substituting the efficiency. Okay, so I will get 15 units minus R equal to 14 units. So if I send this R to the right hand side and 14 to the left hand side, I will get 15 minus 14 equal to R. So I will get 15 minus 14, that is 1 unit of work. Okay, R is completing only 1 unit of work per hour. So to complete this 112 units of work, R totally takes 112 by 1, that is 112 hours. See, understand this very carefully. See here they have given due to some leak it is taking more time. So to find out what is the total time taken for leak to finish the tank, first of all we need to find out without the leak what is the total time taken for P and Q to finish the work. Okay, that is P and Q is finishing 15 units per hour. So totally takes 112 by 15. This is the total time taken by P plus Q to finish the entire work. Now we have got what is the total time taken by P plus Q minus R to finish the entire work, that is 8 hours. So they are completing 112 units of work in 8 hours. So per hour they are completing 14 units of work. This is the efficiency here. See here the difference here is P plus Q minus R totally completing work in 8 hours. So this is the time taken. Okay, now 112 by 8, that is 14 units. This is the efficiency. Okay, this is the total time taken, this is the efficiency. Since I want to substitute efficiency only, I am substituting P plus Q's efficiency in the form of P plus Q. So I will get R equal to 1 unit of efficiency per hour. So to complete this 112 units of work, R takes totally 112 hours. Okay. Now let's see the third problem. They are saying that pipe A alone and pipe B alone can fill a tank in 36 minutes and 54 minutes. Another pipe C can empty the tank in 30 minutes. If pipe C opened for the first 16 minutes, then A and B are also opened in the tank. Find in how many minutes tank will be filled after all the 3 pipes are opened. So we need to find out what is the total time taken for all the 3 pipes to fill the tank. Okay, now they are saying that pipe A can fill the tank in 36 minutes and pipe B can fill the tank in 54 minutes. So A's 1 minute work or efficiency will be 1 by 36. Now B's efficiency or 1 minute work will be 1 by 54. And also they are saying that C can empty the tank in 30 minutes. So C's 1 minute work is 1 by 30. Now C's work is to empty the tank. Okay, so C remove the work that was done by A and B. Okay, now they are saying that in a completely filled tank, C is opened for the first 16 minutes. So for the first 16 minutes, some part of work will be emptied by C. Okay, for the first 16 minutes, C will empty some part of the tank. Now, what is the part of tank that is emptied by C? That is 1 by 30 into 16 minutes. So we will get 2 8s, 2 15s. 8 by 15th part of the tank is emptied by C in the first 16 minutes. So what is the part of tank that is already full? 1 minus 8 by 15 equal to 7 by 15. So C has removed 8 by 15th part of the tank. Now 7 by 15th part of the tank is already full. Now A, B and C all the three are working together to complete this removed part. Okay, see I will write here so that you can understand. Now after 16 minutes A and B are opened. So after 16 minutes A and B are opened with C. Okay, since he is removing the work, that's the reason I am keeping negative symbol for the C. So they are working together. We don't know how many hours they are working. So I am considering it as X to finish the removed part, that is 8 by 15th part of the tank. Okay, see for the first 16 minutes C has removed 8 by 15th part of the tank. Now only 7 by 15th part of the tank is already full. Now what is the total work to be done by A, B and C? That is 1 minus 7 by 15, that is 8 by 15th part of the tank need to be filled by A, B and C. Okay, I hope you are understanding. See, A is removed 8 by 15th part of the tank, right? So only 7 by 15th part of the tank is full now. Now A, B, C need to fill what is the empty tank, that is 8 by 15th part of the tank is empty now. So they need to fill 8 by 15th part of the tank. Okay, now if I substitute all these values here, I will come to know what is the total time taken for them to fill the tank. Okay, now I am substituting 1 by 36 plus 1 by 54 minus 1 by 30 into X equal to 8 by 15. So if I take LCM 36, 54 and 30, 36, 54 and 30, I will get 6, 36 and 6 9s 54 and 6 5s 30. So 3 2 6 and 3 3s 9 5, 6 3s 18, 18 2s 34, 8 2s 36 and 36 3s, that is 108, 108 into 5. 500 and 8 into 5, that is 40, 540. So 540 is the LCM. So 1 by 36 into 540, that is 36 tens 360. So 15 plus 1 by 54 into 540, that is 54 tens 540 minus 1 by 30 into 540. 18 3 is 54. So 18 into X equal to 8 by 15. So if I cancel this, I will get 15 ones, 15 3 is 45 and there will be 45, right? So 9 here, 90, so 6, 15 6 90. So I will get 15 plus 10, that is 25, 25 minus 18, that is I will get 7 by 36 equal of X equal to 8. So if I send this 36 to the right hand side, I will get X equal to 36 into 8 by 7. So I will get 36 into 8, that is 48 and 288 by 7, that is 7 ones 7 4s 28 and 7 1 7, that will be 1 left over and 7 1 7, 3 left over 30, 7 4s 28 and so on. They will get 41.14 minutes. So they totally take 41.14 minutes to fill the entire tank. Okay, I will explain you the problem, see once again, so that you can understand. Here for the first 16 minutes, C is emptying 8 by 15th part of the work. Okay, 8 by 15th part of the tank. So after emptying 8 by 15th part of the tank, only 7 by 15th part of the tank will be left over, that is full. Okay. Now A, B and C need to fill the empty tank, that is what is empty tank here? 8 by 15th part of the tank is empty here. 7 by 15th part of the tank is already full. Okay. 8 by 15th part of the tank is the total work need to be done by A, B and C. So they totally take 41.14 minutes to fill the 8 by 15th part of the tank. Okay. Now let's see how to solve the same problem in LCM or units method. So they are saying that A can fill the entire tank in 36 minutes and B can fill the entire tank in 54 minutes and C can empty the entire tank in 30 minutes. Okay. So here minutes, okay, and here units of units. Okay. Now the LCM of 36, 54 and 30, that is the total amount of work to be done. Now the LCM of 36, 54 and 30, that is 540 units. Okay. Now to complete these 540 units, A is taking 36 minutes. So 540 by 36, that is 15 units per minute. In the same way, B is completing 540 units in 54 minutes. So per minute, B is completing 540 by 54, that is 10 units of work. In the same way, C is completing 540 units in 30 minutes. So C is completing 540 by 30, that is 18 units of work. Okay. Now if they all together combine, what is the total amount of work to be done? A plus B. Here C is removing the work. Okay, that's the reason I am keeping negative sign for the C. Okay, then 15 plus 10, that is 25, 25 minus 18, that is 7 units of work. Okay, if all the together can combine and work together, they can complete 7 units of work per minute. Okay, now they are saying that for the first 16 minutes only C is opened. Okay, so C's work is to remove the entire tank. So for the first 16 minutes, C will be removed some part of the work, right? So for the first 16 minutes, C will remove 18 into 16, that is 288 units. So for the first 16 minutes, C is removed 288 units in this 540 units. Okay. So what is the amount of work that is left over? 540 minus 288. So 252 units. Okay. So for the first 16 minutes, C is opened. What is the C's work? To empty the tank, right? So for the first 16 minutes, C emptied 288 units in this 540 units. Okay. Now A, B and C need to work together to fill this emptied work, that is 288 units. Okay. After removing 288 units, there is only 252 units of water tank is full. Okay. Now what is the work that is left over? 288 units. So A, B and C have to work together to fill this 288 units that is removed by C. Okay. Now A plus B minus C can fill 7 units of work per minute. Okay. A, B and C can fill 7 units of work per minute. So to fill this 288 units, they totally take 288 by 7, that is 7 4s 28, 717 point and 10 will be 717, 3 will be left over, 30, 7 4s 28, 20 again there will be so on, so 41.14 minutes. Okay. So understand this question very carefully. For the first 16 minutes only C is opened. So after that A, B and C all are open. So they totally take 41.14 minutes to fill the entire tank. Okay. Now let's see the fourth problem. They are saying that pipe P can fill a tank in 15 hours while pipe R can discharges 8 gallons of water per hour. And also they both are attached to the tank such that they takes 25 hours to fill the tank. Find the total capacity of the tank. So we need to find out what is the total capacity of tank to be filled. Okay. Now they are given that pipe P can fill the total tank in 15 hours. Okay. So P's 1 hour work or efficiency will be 1 by 15. And also they have given that R can discharges 8 gallons of water every hour. So R's efficiency is 8 gallons of water every hour. Here P's efficiency is in the form of hours, but R's efficiency is in the form of 8 gallons of water. Okay. So they both are different. So if I find out R's efficiency in the form of hours, I can find out what is the total time taken, total capacity of the tank. Okay. I hope you are understanding. See here P's efficiency is in the form of 1 by 15 hours, right? So R's efficiency is in the form of 8 gallons. But if I find out what is the R's efficiency in the form of hours, then I can find out what is the total capacity of the tank. Okay, now I will solve this so that you can understand. In addition to these values, they have given that P minus R equal to 25 hours to fill the tank. Since R is discharging the water, I am giving negative sign to the R. So they both are taking 25 hours to fill the tank. So 1 hour's efficiency or 1 hour work is 1 by 25. Now if I substitute P's value in the P minus R, I will come to know what is the R's efficiency or R's total time taken to complete the work. Now 1 by 15 minus R equal to 1 by 25. So if I send this 1 by 25 to the left hand side and R to the right hand side, I will get 1 by 15 minus 1 by 25 equal to R. So the LCM of 15 and 25, that is 25 2 is 50 and 25 3 is 75. 75 units. So 1 by 15 into 75, that is 5 minus 1 by 25 into 75, that is 3 equal to R. So we will get 2 by 75. So this is the R's efficiency in the form of hours. Okay. Now we have already know that R's efficiency in the form of gallons. Okay. So out of 75 parts, 2 parts of value is equal to 8 parts. Okay. I hope you are understanding. See, here we have known that what is the efficiency of R in the form of hours. So here we have already know what is the R's efficiency in the form of 8 gallons of water. Okay. Now we can simply equate these two because these are both R's efficiencies only, right? So out of 75 parts, okay, out of 75 parts, 2 parts are equal to 8 units, right? 8 gallons of water. So what is the value of 75 units then? Okay, here see, out of 75 parts, 2 parts is equal to 8 gallons of water. Then what is the value of 75 units? That is the total capacity of the tank. Okay, out of 75 units, 2 parts is equal to 8 gallons of water. Now what is the value of 75 parts? That is 75 into 8 by 2. 2 ones, 2 fours equal to 300 gallons of water. This is the total capacity of the tank. See here, I will explain you once again. Here they have given P in the form of hours and R in the form of 8 gallons of water. So if I find out R's efficiency also in the form of hours, I will find out what is the total capacity of the tank. So I am substituting this P's value in the form of P minus R. So I came to know R's efficiency, that is 2 by 75. So out of 75 parts, R is doing 2 parts per hour. Here R is discharging 8 gallons of water per hour. So 2 parts is equal to 8 gallons per hour, right? So then what is the capacity of 75 parts? That is 300 units or 300 parts. That is total capacity of the tank is 300 gallons. Okay. Now I will solve the same problem in the LCM or units method. See, they have given that P can complete the total work in 15 hours. 15 hours. This is hours and this is units. Okay. Now P minus R, that is if P and R both combine, they will complete total work in 25 hours. Now the LCM of 15 and 25, that is 75 units. Okay. Now they are saying that 75 units can be completed in 15 hours. So per hour P is doing 75 by 5, that is 5 units of work. In the same way, P minus R is doing in 25 hours. So 75 by 25, that is per hour they are doing 3 units of work. Now if I substitute this or if I subtract this P from P minus R, I will come to know what is the R's efficiency or what is the part of work that is completed by R per hour. Okay, now I am doing, see, I will get, if I subtract this P from P minus R, I will get minus R equal to 5 minus 3, that is 2 units of work. Okay, so R is discharging 2 units of work per hour. And also in the question they have given that R is discharging 8 gallons of water per hour. So these 2 units will be equal to 8 units here. Okay, but the difference is here we have find out the efficiency in units, but in the question they have given efficiency in gallons of water. So we can simply equate them. Now 2 parts equal to 8 gallons and the total amount of work to be done is 75 units. So 75 units is the total amount of capacity of the tank. So we don't know what is the total capacity of, that is 75 units of work done. So 75 into 8 by 2, that is 2 ones 2 fours equal to 75 into 4, that is 300 is the total capacity of the tank. Okay. Now let's see the fifth problem. They are saying that pipe A and pipe B together can fill 25% of the tank in 8 hours, while pipe C takes 20 hours to empty it. Pipe A and pipe B were opened together. After 26 hours, pipe C is also opened. Find the total time taken to empty the tank this way. So we need to find out what is the total time taken to empty the tank. Okay, now they are saying that pipe A and pipe B are working for 8 hours to fill 25% of the tank. 25% is nothing but 1/4 of the tank. Okay, A plus B is taking 8 hours to fill 25% of the tank. 25% is nothing but 1/4 of the tank. Okay, now if I send this 8 to the right hand side, I will get 1/32. So this is the efficiency or 1 hour's work of A plus B. Okay, now they are also saying that C takes 20 hours to empty the tank. So C's 1 hour's work will be 1/20. Now they are saying that up to 26 hours A plus B are opened. Okay, now up to 26 hours A plus B are opened. So up to 26 hours some part of the work will be completed by A plus B. Okay, now A plus B are opened for 26 hours. So up to 26 hours they will be completed some part of the work in the tank, right? So A plus B's efficiency is 1/32 into 26. That is 2 16ths and 2 13ths. I will get 13/16 part of the tank is already filled by A plus B. Okay, so up to 26 hours A plus B are working together and completed 13/16 part of the tank. Now C is also opened. So after 26 hours C is also opened. So then we need to find out what is the total time taken to remove the tank. Okay, now after 26 hours A plus B minus C. I am keeping this negative sign for C because C is removing the work. Okay, now A plus B minus C, we don't know what is the time taken for them, so I am keeping it as X to remove 13/16 part of the tank. Okay, now only 13/16 part of the tank is filled, right? Now after 26 hours C is also opened, so that we need to empty all the tank that is filled. What is the part of tank that is filled? Only 13/16 part of the tank, right? Now if I substitute all these values in this, I will come to know what is the total time taken to complete the tank. Now if I am substituting this, A plus B value is 1/32 minus C is 1/20 into X equal to 13/16. So if I get LCM 32 and 20, 4 8s 32 and 4 5s 20 and 4 2s 8 5, 4 4 16, 16 2s 32 and 32 into 5, that is 33, 35 is 150 and 2 5s 10, that is 160. 160 is the LCM and 1/32 into 160, that is 5 minus 1/20 into 160, that is 8 into X equal to 13/16. So 5 minus 8 is 3/160, and if I cancel this 16 1 16 tens, and here it will be minus 3. So if I send this 10 to the right hand side, I will get X equal to 13 into 10, that is 130/3. So if I cancel this, 3 1s 3 4s 12, and there will be 1 here, and 10 3 3 is 9.33, okay, 43.33 hours. 43.33 hours. So it takes totally 43.33 hours to empty the total tank. Okay. Now let's see how LCM or units method works in the same scenario to solve the problem. See, they are saying that A plus B can finish the 25% of the tank in 8 hours. So to finish 100% of the tank, it takes, see, 25% of the tank in 8 hours. To finish 100% of the tank, it totally takes 100 into 8/25. That is 25 ones, 25 fours and 8 fours, 32. 32 hours. Okay, here see, they have given that A plus B can complete only 25% of the tank in 8 hours. To finish 100% of the tank, they take 32 hours of work. Okay, so and also they have given that C takes 20 hours to finish the entire tank. Now the LCM of 32 and 20 will be total amount of work to be done. Now the LCM of 32 and 20 is 160 units. Okay, here units. Okay. Now the total amount of work, that is 160 units, is completed in 32 hours by A plus B. So per hour it is completing 160/32, that is 5 units of work. In the same way, 160/20, that is 8 units of work completed by C per hour. Now they are saying that A plus B is worked for 26 minutes. Here see, A plus B up to 26 minutes, A plus B are open together. So up to 26 minutes they have completed some part of work, right? Some part of work. So we don't know what is the part of work. So we will multiply this efficiency into the total time taken. So 5 into 26, I will get 26 into 5, 2500 and 6 5 30. So 130 units of work. So up to 26 minutes, they have completed 130 units of work. So after 26 minutes, they have opened C also. Okay, after 26 minutes, they have opened C also. Now they all need to finish this 130 units of work, because up to 26 units, only 130 units of work is done. I mean 130 parts of tank is completed. So after 26 minutes, they all opened. So they need to empty the tank, that is only 130 parts of the tank, right? So after 26 minutes, they need to empty only what is the work done up to then, that is 130 units of work. So per hour, what is the efficiency of A plus B minus C? That is A plus B minus C. That is, we are keeping negative symbol for C because C is removing the work. Okay, now A plus B minus C, per hour it is doing A plus B, that is 5 units of work minus C is 8 units, that is minus 3 units per hour. In the sense, they are together removing 3 units of work per hour. So to finish this 130 units, they totally take 130 by 3, that is 3 4 12, 3 3 is 9.33 equal to 43.33 hours. Okay, to complete this total 130 units of work, they totally take 43.33 hours. And that's it for this video. Try to solve more and more problems based on this pipes and cistern concept. If you feel any problem as very difficult, you can simply message the problem to us in the Instagram, so that we can pick all the problems that are very difficult and we will make a dedicated video explaining how to solve the problems. Okay, and for more tutorials like this, please subscribe to the channel. Thank you.